Good morning, dear young scientists. You are listening to our School on Air science subject. I hope you fully understand our lesson for today.
Sci Talks Radio. Education must continue.
Learning is a great avenue.
No one will be left behind. With new normal comes new learning.
New method, new way of understanding.
Keep on learning.
Keep on achieving.
There's no way of hindering.
Enriching one's dream.
This is
Sci Talks Radio, your number one source of science education.
Conveying a half an hour of quality scientific teaching on air.
This is Sci Talks Radio.
A lovely day to our grade 10 students. Happy New Year to all of our listeners. This is Sci Talks Radio, your number one source of science education. We are glad to be with you today for the first session of our second quarter. My name is Ma'am Johanna R. Caro, and I will be your guide and teacher for today. Grade 10 learners, I hope that you had a wonderful year-end vacation with your family. Having a vacation clears our mind and makes us feel relaxed. I know you're still thinking of your New Year's Eve celebration, but you already had your fill. Now, it's time to learn amazing science stuff. So, you know the drill. Make sure that you are comfortable and seated in a noise-free area so that you will be able to listen to this broadcast attentively. Please be reminded also that you should already have your meal for you to be able to listen and focus better on our lesson. Also, keep your cell phones in silent mode. Before we start our lesson, let us first check how much you know about our topic for today. Let's try to answer the What I Know part of your module on page 2 up to 4. Are you ready?
Hooray!
Question number 1. These are waves that are created as a result of vibrations between an electric field and magnetic field. A. Electromagnetic spectrum. B. Electromagnetic wave. C. Microwave. D. Radio wave. Number 2. Electromagnetic waves are produced by blank. A. Any disturbance. B. Currents. C. Vibrating charge. Or letter D. Voltage source. Number 3. Which two colors of the light lie at the beginning and end of the visible spectrum? A. Red and violet. B. Red and yellow. C. Yellow and violet. D. Yellow and green. Number 4. This type of EM wave has a wavelength similar to the size of PBA basketball court of 28 meters. A. Microwave. B. Radio wave. C. Ultraviolet. Or letter D. Visible light. Number 5. Which of the following electromagnetic waves has the least wavelength range? A. Infrared. B. Ultraviolet. C. Visible light. Letter D. X-ray. Number 6. What happens to the frequency of electromagnetic wave if its wavelength increases? A. It decreases. B. It doubles. C. It increases as well. D. It remains the same. Number 7. Which of the following forms of electromagnetic wave has the widest wavelength range? A. Microwave. B. Radio wave. C. Ultraviolet. D. X-ray. Number 8. In the visible spectrum, which color has the longest wavelength? A. Blue. B. Green. C. Red. D. Violet. Number 9. Which property spells the difference between infrared and ultraviolet radiation? A. Amplitude. B. Color. C. Speed in vacuum. Or letter D. Wavelength. Last number. Number 10. Which electromagnetic wave can travel the farthest distance because it has a wavelength range of greater than 1 × 10⁻⁻1 meters? A. Gamma ray. B. Radio wave. C. Microwave. Or letter D. X-ray. That's it! Did you manage to answer it all? Hooray! I will now give the answers and let's see how much you know about our topic. Number 1, the correct answer is letter B. Number 2, it's letter C. Third item, the correct answer is letter A. Number 4, B. For the fifth question, the answer is letter C. Number 6. The correct answer is letter A. Number 7. It's letter B. For number 8, the correct answer is letter C. Number 9. The answer is letter D. And for the last item, the correct answer is letter B. How many did you get? Is it a perfect score? Or a score higher than 7? Yay! If so, then you already have an idea about our topic. If you got a score lower than 5, then you need to listen more about our topic for today. I guess we are now ready for our new lesson. This is the first lesson of the second quarter and also our first lesson this new year 2021. Before we start, you may need to find a rope for our activity later. Any kind of rope will do. Of course, you should have your modules with you and your answer sheets. Go over your things once again to make sure that you already have all that you need. Our lesson for today is about the different forms of electromagnetic waves or EM waves. Oh, yeah! When you were in grade 7, you already had a lesson about waves. Let's remember first some important terms about waves. Take a look at page 5 of your module. The answers are in jumbled letters. I will read each item and you will try to guess the answer by arranging the jumbled letters. Number 1. It is a disturbance in space. That was simple and easy one, right? The answer is, obviously, it's wave. Did you get the first one? Very good. Number 2. It is the highest point in a wave. Maybe that got you thinking, but the answer is correct. It's crest. Number 3. It is the lowest point of a wave. Don't be confused by its spelling. The answer is trough. T-R-O-U-G-H. Trough. Let's have number 4. It is the distance from the midpoint to the highest or lowest point of a wave. And what is your answer? Is it amplitude? That's correct. It's amplitude. Number 5. It is the distance between two successive identical parts of a wave. The jumbled letters must be confusing, but it's an easy one too. The correct answer is wavelength. Let's proceed to number 6. It refers to the number of waves produced in 1 second. Did you answer frequency? Yes, that's the correct answer. Number 7. It refers to the extent or the limits between which variation is possible. That was a difficult one. But if you answered range, then you are correct. Did you get all of them correctly? Try to remember and keep in mind all these 7 terms. We have wave, crest, trough, amplitude, wavelength, frequency, and range. We will be dealing with these terms as we go over this module.
Alright.
Have you seen a wave? Of course, you've seen waves, but have you created one? How about if we try to make some waves? I told you a minute ago to prepare any kind of rope, right? Please bring it out and tie it to your table or to your chair. Hold the other end of the rope. Walk a distance from where you tied it and then straighten it. Now, start moving your hand. That is holding the rope up and down. Were you able to make a wave? It's easy, right? Draw the wave you made on your answer sheets and not on your module. Are you done? Great! Now, try to make a wave again, but this time, move your hands slowly. Again, draw the wave you made on your answer sheet. And finally, make a new wave, but this time, move your hands fast. Draw the image of the wave you made on your answer sheets. Let's answer the question on page 7 of your module. Based on the activity, is there any difference on the waves you created? What do you think? Yes, definitely. The 3 waves that you created are different from one another. But why does each created wave look differently? You created the wave on different speed. In the first wave you created, your hand moves up and down in normal speed. In the second wave, you move your hands slowly. And in the last wave, you moved your hands fast. All the waves you created may look differently depending on how fast you move your hands. Similarly, if you move an electrically charged object back and forth or up and down in an empty space, you'll create an electromagnetic wave in space. But what is an electromagnetic wave? Electromagnetic wave or EM wave is a wave that is created as a result of vibrations between an electric field and magnetic field, hence it is known as electromagnetic wave. Recall Ørsted's discovery. Changing electric field produces magnetic field. A changing magnetic field is therefore produced around a vibrating charge. And according to Michael Faraday, the changing magnetic field will produce electric field. A wave carries energy as it propagates, and EM wave does the same too. EM waves can travel through anything, even on vacuum, meaning they do not need any medium to travel. They travel in a vacuum at a speed of 3 times 10 to the 8 meters per second, or that is 300 million meters per second. Wow! You can't catch it. It's too fast. There are 7 different types of EM waves. They are arranged from lowest frequency to highest frequency. This arrangement of EM waves is called electromagnetic spectrum. In order of increasing frequency, the EM spectrum includes radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma ray. Now, let's try to answer the enrichment activity on page 8 up to 10 of your module. Using figure 1 on page 9, you will determine the wavelength range of each of the forms of electromagnetic waves. On a separate sheet of paper, copy and answer the given table on page 10. Afterwards, answer the questions that follow. Take note that wavelength is the distance between crest to crest or trough to trough. EM waves are bounded at different ranges, meaning each type of EM waves has upper and lower limits on the spectrum. Firstly, take a look at page 9. Facing the figure, we can see that from the left, there is the radio wave with the longest wavelength. You can see the drawing on the top of the radio wave, the basketball court, and human. That drawing is to give you an idea how big or long the wavelength of the radio wave is. Wow! Radio wave is as big as a basketball court or human. Next is microwave. Its wavelength is the size of a coin. Followed by infrared with a wavelength comparable to the size of the tip of a pin. Then, we have visible light with its wavelength as small as bacteria. Moving on, we have ultraviolet with a wavelength similar to the size of a molecule. Then, X-ray with its wavelength akin to the size of an atom. And lastly, gamma ray with an even smaller wavelength, only the size of an atomic nuclei. As you can see, they are arranged from longest wavelength to shorter wavelength as we have mentioned before. Now, you may be curious why a radio wave, given the size of its wavelength like a basketball court, we can't see it at all. That is because of what we call the biological limitation of our sense of sight. Our eyes can only see from 400 to 700 nanometers of the EM wave's wavelength. This range is called the visible light, hence it is called visible because it is the only EM wave we can see. So, don't feel bad if you can't see other 6 types of EM waves. They are just meant to be invisible to our naked eyes. Let's now fill up the table on page 10 of your module. Kindly copy the table on your answer sheet. What do you think is the wavelength range of radio wave? Yes, It is more than 1 times 10 to the negative 1. You can write it down on your table. Next, microwave's wavelength range is, based on the figure, it's 1 times 10 to the negative 3 to 1 times 10 to the negative 1. Next, the infrared's wavelength range is, can you guess it? Very good. It's 7 times 10 to the negative 7 to 1 times 10 to the negative 3. And now, the visible light, what do you think is its wavelength range? You got it. It's 4 times 10 to the negative 7 to 7 times 10 to the negative 7. If you can see, visible light is divided into 6 colors. Can you guess the colors? Exactly. They are the colors we often see at rainbows. We have red, orange, yellow, green, blue, and violet. Let's start with red. Its wavelength falls between 6.22 times 10 to the negative 7 to 7 times 10 to the negative 7. Orange falls between 5.97 times 10 to the negative 7 to 6.22 times 10 to the negative 7. Yellow is in between 5.77 times 10 to the negative 7 to 5.97 times 10 to the negative 7. Green will be at 4.92 times 10 to the negative 7 to 5.77 times 10 to the negative 7. Blue is in between 4.55 times 10 to the negative 7 to 4.92 times 10 to the negative 7. And violet, it is in between 4 times 10 to the negative 7 to 4.55 times 10 to the negative 7. Did you get all of that? I hope that you are listening and taking notes right now. Let's move on to ultraviolet. Can you guess its wavelength range? Of course, it's 1 times 10 to the negative 8 to 4 times 10 to the negative 7. Next, we have X-ray at 1 times 10 to the negative 11 to 1 times 10 to the negative 8. And lastly, gamma ray with its less than 1 times 10 to the negative 11 meter wavelength. Take note that the unit is given. It is on meters.
Alright!
Did you get all the wavelengths? If you did, then you've done a great job. We are not done yet. Once again, take a look on page 10. We will now answer question 1 to 3. Are you ready? I know you are. Question number 1. Which electromagnetic wave has the longest wavelength? If you are really listening, then you already know the answer. What is it? Very good. It is the radio wave. Question number 2. Which electromagnetic wave has the shortest wavelength? This will be easy now, don't you think? Just take a look at the end of the EM wave spectrum and you will find the answer. So, what is your answer? You are correct. The answer is gamma ray. Last question. Does the wavelength of the EM waves increase or decrease as we go from radio wave to gamma ray? Let's take a look at the figure on page 9 once again. From the wavelength of radio wave to gamma ray, what can you notice? Is it increasing or decreasing? It's easy, right? The answer is decreasing wavelength. Were you able to get the answers correctly? If yes, then very good. Before we proceed to our short quiz, let's first do a recap about our lesson for today. We learned today that electromagnetic waves are produced between an electric field and magnetic field. And it all starts with a vibrating charge. We also learned that EM waves can travel through anything, even in vacuum or in outer space. EM waves can travel in a vacuum at a speed of 300 million meters per second. EM waves have 7 different types and are arranged on what we call as electromagnetic spectrum. These 7 EM waves are radio wave, microwave, infrared, visible light, ultraviolet, X-ray, and gamma ray. We learned that EM waves are arranged in decreasing wavelength on the spectrum. Radio wave having the longest wavelength and gamma ray having the shortest wavelength. And we learned that visible light is divided into 6 colors. They are red, orange, yellow, green, blue, and violet. They are arranged in decreasing wavelength in the spectrum. Wow! We have learned so much in one day. I hope that you will remember all of what we have discussed for today. Now that we are done with our lesson, let's test your knowledge on today's episode. You can write your answer on your answer sheets. Just write Assessment 1 so that your teacher will know where to record your scores later. Are you ready? Set aside your notes and modules. Listen carefully. We only have 5 questions to answer. Write the letter of the correct answer and remember, it should be written in capital letter. Okay, let's begin your first short quiz for the second quarter. Number 1. This type of wave was discovered by famous astronomer Sir Frederick William Herschel and has a range of 7 times 10 to the negative 7 meters to 1 times 10 to the negative 3 meters. A. Infrared. B. Microwave. C. Radio wave. D. Visible light. Number 2. Which of the following electromagnetic waves has the least wavelength range? A. Infrared. B. X-ray. C. Visible light. D. Ultraviolet. Number 3. Which among the following EM waves has the longest wavelength? A. Infrared. B. Ultraviolet. C. Visible light. D. X-ray. Number 4. Which electromagnetic wave can travel the farthest distance because it has a wavelength range of greater than 1 times 10 to the negative 1 meters? A. Gamma ray. B. Microwave. C. Radio wave. Or letter D. X-ray. Number 5. The wavelength of microwaves ranges from 1 times 10 to the negative 1 meters to 1 times 10 to the negative 3 meters. Which of the following has size comparable to the wavelength of microwave? A. Bacteria. B. Coin. C. Human. D. Pin. That ends our short quiz. Did you manage to answer all? Make sure to leave no blanks on every item. Also, make sure to go over and read your module once again if you have spare time. At this point, let us see how well you understood our topic by checking your answers on our recently concluded quiz. Please check your answers with all honesty. Number 1. The answer is letter A. Second item, it's letter C. Next, letter A. For number 4, the correct answer is letter C. Finally, the answer for the 5th question is letter B. Please count the number of checks. How was it? Who among you perfected the quiz? Commendable learners! Keep it up! We are now done with one lesson and one activity. You can always read your module in advance. Our next lesson will be about the practical applications and effects of electromagnetic waves. Make sure to tune in here at SciTalks Radio. Before we finally end, our warmest greetings and appreciation to the writer of this script, Sadiri Laborta III, together with the RBI production team. Till next time, everyone. I am your science teacher for today, Ma'am Johanna R. Caro. Always remember that New Year brings new opportunities for us to give our best at everything at the start. And this start will determine how much success we are going to harvest later on. Happy New Year to all and have a blessed 2021.